Hello folks. So in this video I just want to go over describing associations. Now I know that you've talked about this a little bit in maybe previous courses, but I just want to make sure we're all on the same page, and so if I ask you to describe an association, you know what I'm asking for. Now describing an association just asks you about four main things, which are found right here. So there's form. Some people also call this shape, so I'll say form or shape. Then we have the direction of the association, the strength of the association, and are there any outliers or not. So we'll go through these one at a time, and then we'll do an example at the very end. Alrighty. So the form of the association again is really just the shape of the data, and you can think of it as what type of graph does it look like. Now we have a number of graphs that we've seen in this course, right? So let's see, I'll say graph shapes. So the main one that we've seen so much of is linear. Right? Does the data look like if forms align? And again, it's not going to be, because this is data, right? You're running an experiment and you're collecting data. It's not going to be perfect. It's not going to, all the data isn't going to align exactly on a line, because that's just really not how our experiments turn out. But does it generally look linear, or does it maybe look exponential, or does it look like a quadratic graph, or parabolic? I'll say quadratic or parabolic. Right? Does it look like a parabola, a U shape, or upside down U shape? Now, in the book, you'll see it mainly describes it as linear or nonlinear, because this chapter comes before the exponential functions chapter or the quadratic functions chapter. But since we've already talked about those, I think it's always helpful to be more descriptive rather than less. And so you can clearly see it as exponential or quadratic. I would like you to say that. There's also this idea of clusters, which is added on in addition to the shape of the graph. And so you would say that there are clusters if the data is, well, clumped up or grouped together. We can see some examples down here at the bottom right here, these three examples. Let's go over direction before we get onto that though. Okay, so that is form or shape. The next one is direction, and direction is, you can think of it as the direction of the slope that is that your data follows. If you see that, it's easiest if we use linear as an example. You see if the data or your line of best fit has a positive slope, it has a positive association. Likewise, if the slope is negative, then it would have a negative association. So really, the words you're looking for when describing the direction are positive or negative right here, underlined in red. I'll write that over here because I think maybe that deserves to be written down. So when talking about the direction, so a positive association if, another way to say that is if as one variable increases, the other also increases. That'd be a positive, and then if it's negative, that'd be if one increases while the other decreases. As one variable increases, the other decreases. And we should see that here. So let's look at these three examples. I'll number them here. And they're already kind of labeled with the answer on there. But so in this first one here, you can see it's a negative association, because as you go to the right, as our horizontal variable, whatever that is, so maybe this is like age, right? And then maybe our dependent variable here is maybe maybe you're running a mile and your mile time. goes. So as you get older, you run a little bit slower, which makes sense, I think. And so since our slope is going downward, we say it's negative. And the data, in general, it looks like it fits like a straight line shape pretty well, and that's why it's a linear association. And the second one here, now could I draw a straight line of best fit on the second one? Yes, you absolutely could. It could go like that. But try to think, since we have some data, there's a little pattern to the data, and this will come up later. The pattern to our data, once I draw my line of best fit, is it's a little bit above the line, then below the line, and then above the line again. That kind of suggests that this model that we use, in this case a linear best fit line, is actually not the best idea. You can kind of see, instead of using a linear one, I think this one would actually be best if we used a model that looks like that. That is clearly not linear, but we can actually say a little bit more. It looks like an exponential graph. Exponential. We could also say exponential decay because it's going down. Right, so not only is it nonlinear, we could say it's exponential. And once again, as our x variable increases, our independent variable increases, then our dependent variable goes down, decreases. And so since they're going in opposite directions, that's again a negative association. This is the last example here. This one includes clusters because you can see the data is kind of in two main bunches. But if we look, kind of zoom out a little bit, so take away the cluster idea from your brain, is that this data does look fairly linear because it seems to be a fairly good fit for this line of best fit. And so that suggests a linear fit's pretty good. And then once again, as our x variable increases, our y variable also increases, and so that suggests it's positive association. Hopefully those two make a little bit of sense now, the form and direction of our association. Another big idea is strength. And so the strength just says, well, how close to our line of best fit is our data. And so usually this will be, one way to think of it is how easy is it to draw a line of best fit. If I take, let's say my line of best fit is right here, on this first data set, like it's pretty easy to draw one that goes kind of through all the data. And I say, so there's many ways to draw a line of best fit, like using your eyeballs. So I might use this line of best fit, but maybe you would rotate it a little bit, maybe put it down there or a little bit higher, and so on. We're going to talk later about how the computer creates that quote-unquote best line of best fit, but we won't talk about that yet. You see here, like, you know where the line of best fit is going to be in general. It's going to be really obviously around here. So that's just a strong association. In this one, the line of best fit, because the data is so spread out, I think that there's a lot of variability. Like, I might put it here, but maybe you would put it down here or up here and move it around a good bunch. And which one's the best? Well, it's kind of hard to say. And likewise, on the weak association, the data is really spread out. And so there's a whole wide range of where our line of best fit might go. And so again, the strength of the association really just says, well, how far away from our line of best fit is the data. The last bit is outliers. And I think this one, you have a good idea of what this is are there any data points that kind of look like they don't belong? They might have been a mistake when you did the experiment. So this text got a little messed up, but here's the outlier in this data set, where you have all your data clumped up around here in this what looks like this curved data set, but sorry, I draw right there, and then you have one that looks like it's kind of a mistake, and so we'll call that an outlier. Now there is a mathematical way to determine is something actually an outlier or not. We won't talk about that in this course, because sometimes like that there's no explanation for an outlier, but it just is the way it is. Like, it's totally possible I did my experiment totally correct, and that's just where the data point lied. The question you might want to ask yourself then is, how weird does an outlier have to be called an outlier? Because like I might have a data point like this red one right here, but that's kind of close, but it also looks kind of not close, and so it's at least as far as it goes in this course, we will make the outliers fairly obvious. Okay, so I just want to run through one example of this. So let's actually describe the association for this data set right here. And I want you to pause the video and come up with a description for it on your own, and then come back to the video, resume it when you have, your report. Okay, so I'm going to assume that you've done that. And so the things we need to look at are the strength. I usually put the strength first. I don't know why. We need the form, the direction. Actually, sorry, I usually put, for some reason, I put the form last, or third to last. Direction, not third to last, third rather. The form, and any outliers or not. Okay, so the strength of this one, well, the data does look fairly it fairly, excuse me, it fits this kind of curve pattern fairly well. So I would go so far as to say that it is a strong association. The direction, well, you can see as in general, your data is following this upward slope here. And so that tells me it's a positive association. Excuse me. The form. So let's see, what kind of line of best fit would work best? So I could draw a straight line through there, and it looks fairly close, but I think it would be better if we didn't use a straight line, we actually use a curved line like this. So I could say it's nonlinear, but since we know more than just nonlinear or linear, I think that this one looks pretty close to an actual exponential curve. So I'm going to say nonlinear slash exponential. And are there any outliers? Well, we kind of already pointed that one out on this one. So with one outlier, we'll say. Okay, and that's how you would describe this association. So sorry, the instructions for this question. Describe the association, which is this one we're talking about. One question you might ask yourself is how strong is strong and how weak is weak? If I go back to this video, or sorry, this section over here, you're right in thinking that it is totally subjective. What I think is strong, you might only think is moderately strong, and so on. And so, most for our purposes, you can generally consider the only options being strong and weak, and kind of throw out the moderate part unless it's obviously moderate. So, what I mean by that is the problems I'm going to give you are hopefully clearly strong or clearly weak. And if you can't tell it's clearly strong or clearly weak, then it must be moderate. But I hope that makes sense. Again, it does definitely leave room for interpretation, which is kind of the whole point of this chapter, because this is all about how do we gather data and then how do we interpret that data. Okay, so it is definitely subjective, but this video hopefully has now helped you figure out what you need to say when I ask you how to describe an association.